Hello, everybody, and welcome to today's webinar presentation, How to Migrate to NoSQL Without Changing Your Whole Schema, brought to you by Couchbase. I would like to introduce you to our presenter, Benjamin Bryant. Benjamin has a broad technical background of over 22 years, including over 10 years experience in distributed object storage, SQL databases, and performance architecture and engineering in software, hardware, and networking. He has been with Couchbase since March 2014 and working with customers on SQL++ for JSON since 2015. As Director of Developer Advocacy, Benjamin and his team attract and inspire developers to collaborate within the Couchbase ecosystem, expand our collective technical influence globally, and bring more mindshare to bear on our solutions. So with that, Benjamin, I'm going to turn things over to you to begin the presentation.
Thank you. I'm happy to be here. This presentation was inspired by a question from my last session on DZone, and so I'm eager to get started. I'm Benjamin Bryant, the Director of Developer Advocacy for Couchbase. I've been, as you heard earlier, with Couchbase for about 5.5 years. I started as the first engineer here in the central United States, and in the sales side, and I moved into developer advocacy about a year ago. The agenda today was inspired by a question that was asked in our last session. And when we're migrating relational data to NoSQL, there's some challenges there, and we're going to talk about that here in the first section. We're going to talk about the solution that in representing your relational data as JSON in Couchbase and how to query that. And then after ingestion into the NoSQL system, what then does it look like to sort of experiment with denormalizing? We won't get into things like stored procedures. We won't get into things like production-ready data sync or anything like that. But we are getting into getting the data into Couchbase first, and dealing with the relational data in its current schema. So first off, I'm going to kick this off with a brief micro demo. In case, for those of us who are attending who are not familiar with SQL++ for JSON, or NICL as it's branded in Couchbase, we're going to walk through just a quick introduction to our online query tutorial. We're going to run my signature query from the previous slide that you saw, and we're going to look at that real quick. So without further ado, I'll do the Google search here, and you can do this yourself. Couchbase query tutorial. And this is where the NICL language tutorial is. It's got a bunch of lessons in here that you can go through a little bit later. In this query field, we can put in my query from my signature slide. So let me grab that really quick. We'll paste that in here. We'll run that. And so you can see a little bit now how NICL is a JSON data processor, basically, and its results are in JSON form. You see a JSON string here with the associated attributes. There's a signature object that contains 4 attributes, one of them being the company, one of them being this array of contact items, and then my name and the role. And so there's a quick just intro, sort of the nested data structures that our projector is able to do. And we're actually going to use this a little bit later here in the presentation. Okay, so micro demo complete. Back to the presentation. Okay, the challenge, data migration of relational data to NoSQL. We all know that data demands are expanding for a variety of reasons in the modern time here. We know that our relational systems are challenged in terms of being able to deliver on our application promises to the world. So this is kind of where NoSQL fits in, and this is where Couchbase fits in. You may know from a previous session that Couchbase is a multi-process clustered distributed architecture. that's seamlessly managed by our cluster management framework. So we give you the ability to do very sophisticated, complex work and scale it dynamically with 100% uptime using this architecture. So we know that. We have JSON data sets in Couchbase. We know that we can query them now with SQL-like syntax that's called NCL. So if we have a relational schema like this one on the left, which is about 10 tables, we know that we can take it over to Couchbase on the right. We know that we can denormalize the data for efficiency in getting it over there. And we know that we can run a SQL-like query in order to get similar results out of the denormalized data set. But what if we don't know how we want to denormalize it yet? And this is the challenge. What if we don't know whether I want to go to 4 objects or 5 objects or 7 or whatever? And I don't want to even figure that out, but I really want to get over to Couchbase. I really want to get into a NoSQL system, but I don't necessarily want to have to go through denormalization first. So can I just run this other query for now? Well, that's a good question, and there are plenty of reasons to ask this question. We may have pressures on the relational database system that we need to alleviate sooner, especially when it comes to just sort of object storage and retrieval kind of data traffic. We might be trying to move to the cloud or microservices. We might be trying to achieve elastic scalability for a certain data set. We might want 100% uptime. We might want geographic distribution for the data set. We might want some of the advanced capabilities of a system like Couchbase, the built-in full-text search, the built-in MPP query engine for complex queries. We might want the mobile capabilities, etc. We might want to do some of these things, and Benjamin, I don't really control the data model of the application, but I really want to go over to Couchbase and start experimenting. Well, these are all great reasons to want to take our relational data over to Couchbase. So real quick, next micro demo here is let's look at the schema that we're going to be working with. This schema is it came from a relational system. It's got 3 tables in it, which we'll see here in a second. And we're looking for these 3 tables will be joined together for a consumer profile group instance object, is what it's called, the CPGI object. And so I've got a JavaScript. I got some code in Node.js that will join these 3 tables, and we'll take a look at the output real quick to see how it comes out of the relational system right now before we actually get into migrating. Okay, so back out of there. All right, so oh, sorry. SQLite 3. Okay. So I've got 3 tables in this schema. You see, I've got the consumer profile group. I've got this consumer profile group instance table, and I've got a consumer profile val. And when we join these together, it's really the instance that relies on the group, which is there's a one-to-many from an instance to group, and there's a many-to-one, many instances mapping to one group, many values mapping to one instance. And so we'll see how this works a little bit later. Now let's go over here and look at this first script. This script is something that if you saw my last session, you saw a version of this script. It's going to query the SQLite. It's got 2 queries in it. The one that does the first level of the 3-way join here, the group consumer profile group instance, mapping to the consumer profile values, and then the group object itself. Then for each of those, we will go back in and populate the values for a values array below that object, and then we'll map all of these to a document basically, and then we'll just display those documents on the screen. Okay, so here we go. We'll run this guy real quick. Okay, so you see here we have a whole bunch of results, and this last one we can just kind of take a quick look at. Here's the key, and then here's the document. I've got all of my root level stuff, and then I've got my vowels array with all of the different vowels that were brought in. And so I've got 100 of these results that came out of the SQLite database, and this is what the data should look like as we keep going forward through the demo. Through the presentation. Okay, moving on. We'll go back to the presentation. Okay, the next section, relational JSON data, getting this into a Couchbase in JSON. So for those of us who have not heard of JSON, which are probably pretty few, I'm going to blast through this really quick. JavaScript object notation. It's a subset of JavaScript hierarchical. It's the most common data interchange format today. The data types it supports are objects, arrays, numbers, strings, booleans, and nulls. Why JSON for data? Because it's easy to read and write, and it's ubiquitous. This is actually old statistics. It's even more ubiquitous than this now. There's a standardization effort in RFC 8259. They make great documents because objects and their hierarchical nature map to documents and subdocuments, and the internal key value pairs map to what we call attributes and documents very cleanly. So when we take relational data over to JSON completely flat, this is kind of what it looks like. So on this left side, you see a relational database with two tables, each of those two tables having two records. Now, when we take these over to JSON, we see that we have in this case, we're using the Couchbase best practice of adding a type attribute to the user document to help distinguish it. We also use a user key prefix for the primary key or the ID of the document. So this one here is user : blue 123-4, which is the first record here. Its age is 42. Its name is Betty Blue, and the admin is true. So in here we explicitly name in each one of the documents the attributes within that document, and this is how we take just flat data straight over into documents. So we've got 4 documents here, 2 user documents and 2 product documents, and this is the format that we will use going forward. Now there's another aspect to this that we're going to use, and this is this aspect of referring. And so here's an example of like an order document that's got a built-in array of product IDs, and these product IDs map to these ID documents here that each also have their corresponding product IDs. And now someone here could potentially do a direct lookup join on the IDs of these products in order to fill out this items array. We're not even going to have the array in the CPGI document anyway, so we're going to have to build the array on the fly. But we're going to be using ANSI joins in order to do this. One quick note on timestamps, and you're going to see an example here of how not to do timestamps. But we do need to make sure that when we pull timestamps out of the relational system, that we pull them out either in ISO 8601 format or in the epoch time. I see less common the actual time component arrays, but either in the string format or the epoch time format in order to work in Couchbase. So let's keep that in mind. And now here we are. We're going to now take the relational data and write it into Couchbase. Okay, I don't actually have Couchbase running yet, so we're going to take it and we're going to run Couchbase and we're going to set up our single node cluster in Docker. We are going to import the 3 CSVs that were the source for that relational data. I'm going to show you the page that actually sort of gives us instructions on how to use the CB import tool. And then we're going to run these commands in order to bring forward into Couchbase the 3 document types. You see here I'm prefixing, I'm using this -G parameter for a key. It's the key generator parameter for the data import tool. And we will be prefixing the keys with this doc type tag that we're going to use throughout the rest of it. Okay, so let's get started here. All right, so step one. Couchbase Docker getting started. So we've got some pretty good instructions here on going down into multi-node clusters and everything in Docker using Couchbase and Docker. I'm going to stick with this single node, and it's this command right here. And if I run that, I can run a single node of Couchbase here at about 30 seconds. I'm going to enhance this this command with a -v, which you'll see here in a second, which will map my local file system, so where the actual CSV files are. Okay. All right, so I ran docker run -d. I named my my instance DB. I did some port mapping here as it shows in the command down here, and then I added the -v to my local file system. So that instance is starting up. Now, in order to access that, I've got to access it on 8091. I'm going to set up my new cluster. Accept the terms. Okay. Now here, I only need 3 services. I need the core data service, the index service, and the query service. I'm going to deselect full text search, eventing, and analytics here. And just for me, I'm going to keep it fairly lean here today, and go with the minimums here, 256 and 256. I'm going to leave these to the default, save and finish. Okay, it brings us up to the dashboard. If I go to the servers tab here, you see I've got my one local server. And I have no data bucket, so I'm going to configure a bucket. I'm going to call it profiles today for our purposes. I'm going to give it 100 megabytes of cache. Okay, profiles bucket created. Now it's time to import some CSV data. And I need to do that using the CB import utility. The CB import utility is actually on the Couchbase node. So what I'm going to do is open up a shell on Docker inside the container. So I now have a shell running on the Docker container on which Couchbase is running on my system. Now I'm going to run CB import a few times. This first one was for the consumer profile groups. The second one here. You see I've got 4 items here. Now I will have another 20,000 show up here, and 20,004 in my database. And this last one will be 50,000. Okay, so now I total 70,004 documents. Okay, so if I go into my documents link here on my bucket, I can actually go and look at some of the data. So this consumer profile val for example, and I can see the data that came from the relational system. There's a bunch of extra stuff in here that I probably don't need, but nevertheless, I'm not going to query some of this stuff, but I have it all in Couchbase now. Now, what I don't have in here is it's a doc type. As you saw in my example in the slide, it is a Couchbase best practice to have a doc type attribute added in here. I'm not going to go through that step. Instead, I'm going to do all of my filtering using just the key prefix here for now. So just keep that in mind. Okay. All right, back to the presentation. Querying. So when we have relational data, of course, we're going to need to query the data. We want to use a join syntax in order to get that done. Now, Couchbase supports ANSI joins. We don't need to really pitch ANSI joins here because we are already using them in the relational system, and we want to continue to use them here. We can use the same arbitrary expressions with the standardized syntax and the separation of join conditions and filter conditions. So it's very similar to what you've been using already. The only wrinkle here in Couchbase is, unlike a relational system that is a closely bound set of query functionality, data storage functionality, and index functionality within the same process, in Couchbase, these are actually distributed across different services. There's one service for the actual fast document retrieval. There's one service for the indexing, and there's another service for the query service. And these all communicate with each other over REST APIs. So there's inherent inter-service, you might say, overhead or potential latencies, especially when they're living across different nodes. And so indexing is key. And so making sure we get the indexing right is key to getting good join performance in Couchbase. So we can't just jump in and start running the same query in Couchbase and expecting it to work right off the bat. We got to do a little bit more work. So the first bit of that work is to break down the queries. And so look at what's being drawn from the different document types and distill this out. And in this case, I've got one query mapping to each of the document types that we've just imported that represents everything that we're asking for in the two relational queries before. Now there's some adjustments that I have to make here, right? So you can see in this first select, I've got these in my projection, which map to these 4 items here in the projection of the original query. But I have to go from the profiles bucket. I'm not going from a table like I was in the relational system. I have to go from the profiles bucket. All 3 documents, the 3 document types are existing in that profiles table. Okay, so I have to go there, and then I have to filter for the document type that I'm interested in. So this meta profiles ID is a function for getting the metadata and getting the idea, and then filtering that based on its prefix. So consumer profile group instance is the one here that I want to filter for. And then I want to make sure that I have the predicates that I'm looking for. So the consumer profile group instance ID is something that I'm using in the join, and the consumer profile group ID is also something that I'm using in the join. So I need to have both of those in this query. And so this query here represents what it is that I'm doing on the left side. Likewise for the second query, the consumer profile val document, I need to be able to project these things, and I also need to be able to filter for the consumer profile instance ID when I'm looking for particular consumer profile vals that are applicable to that particular ID. And on the third one, where I'm looking for the profile group, I'm really looking at that consumer profile group ID there. So the reason I did this is because this is going to tell me what indexes I need to create. And so I'm going to need to create indexes. And right off the bat, if you're doing ANSI joins in Couchbase, what I do is always start with covering indexes. It just gives you the best performance out the gate. When I'm validating these queries up front, I'll use a primary index because I have a small data set. But when I want to actually start testing the validity of the ANSI join itself, when I bring it back together, having covering indexes is really essential. You can't rely on repeated key scans over and over and over again in order to get decent join performance. In fact, some joins will never even complete that way. So this is what we have to do, and I'll walk you through this in the demo coming up. And so after we've got the indexes, we can then assemble our nickel join, which is bringing all of this stuff back together with the associated changes that we've made. You see I've highlighted the profiles here. I've highlighted the different projections here from the other queries. And the only thing that's changed from the original queries at the end of the day is that I've had to add, I've had to change the from clauses to go from profiles, alias them with the document types I'm looking for, and then add the additional filter for looking for the key prefix there before I do the comparison in each of the join levels. So I know that was kind of a lot, but it'll make more sense, I think, as we go through it and walk through this together, which we're going to do right now. So the next demo, we're going to validate the 3 breakdown queries. I'm going to break down the queries for you. I'm going to show those to you in the Couchbase query UI. We are going to create a primary index to just sort of validate those, and we're going to run those queries. Then I'm going to create the 3 supporting indexes and reevaluate the queries, and you'll see how the performance gets boosted. I'm going to drop the primary index after that. Then I'm going to run the new join, the new nickel join, and the vals lookup queries. And we're going to look at we may have time to look at the query plan there. And then I'm going to run those in actual JavaScript after that. And so you can see those. Okay, here we go. All right, so query tab. Quick time check, I've got about 15 minutes. All right, we're gonna get rid of this. All right, our first breakdown query. Actually, before I do that, I need to create create primary index on profiles so that I have an index. And if I don't have an index there, it's going to tell me that I need an index. So, all right. Here's my first validation query from the brown box for the consumer profile group instance documents. I'm going to execute this one and just show you the results. And you see, it is fairly slow because it's doing a full key scan of the bucket in order to facilitate the query. And this is what the primary index does. Every query, the query processor is literally downloading all 70,000 documents and filtering them in order to do this. So that's why you see the latency there. But okay, so I have the results here, and I have 20,000 results returned. So I'm in good shape here. The next breakdown query. This one for the consumer profile vals. I'm going to execute on that one. This one should return 50,000 results in roughly the same amount of time. 6.5 seconds, 7 seconds, and I've got about 50,000 results there because I have distinct in here, so less than 50,000. So, all right, that worked. Now my third validation query. For the consumer profile group. I should see 4 here. It'll take the same amount of time because it's downloading 70,000 documents, but I've got 4 results come out of that. Okay, and this little guy here, we do some automatic profiling of the data set The sample that was actually taken by Couchbase, so its sample, what's in here, didn't include these 4 documents. They're statistically low, and so it didn't get. That's all that's telling us there. That's nothing to pay attention to at the moment. Okay. All right. So let's create the indexes. So for that first query that I ran, in fact, let's just start from the bottom up. Let's start for this query. I need to have an index that filters on this, that has this first in its projection, and then my other projected items in its list. So you're going to see an index that has these characteristics here. Okay, create index. I'm filtering for this specific document type. So the index will only have that document type in it, and then it will have the group ID, the group code, and the group description in it. I'm going to execute this one. Okay, next index. Filtering for the profile vowels, right? And then I need to project the filter condition first, and then the other attributes I'm actually going to be projecting or comparing in the query. Third index, the profile instances, the profile group instances. Again, filtering for that, and then the filter condition attributes, and then of course the ones I'm going to be projecting in my projection. So these will be full covering there. Okay. Now, when I go back and rerun my first breakdown query, the 630 milliseconds to retrieve all 20,000 instances. So there's a big difference there between the 7 seconds I was seeing earlier and now this, because I'm coming fully out of the index. And you can see this in the query plan. You can see index scan here, filter, project, and stream. And so this is good. What I don't see is something called a fetch here. If I see fetching, that means I'm going into the document store and retrieving documents, and that tends to be slower. So, okay. Where am I at here? Okay. Now the assembled join queries. So I'm going to assemble the join. Now our full join here, let's see, let's pull this over a little bit. Click that, execute this guy. Okay, 2.6 seconds, roughly 3905 is my result count. This is what I expect. And so what I've done is that first join, and so you're seeing here the stuff from the group instance and the group itself, and then the distinct from the consumer profile val instances there. So all of that is coming back normally, and we can look at the plan here really quick, and you can see here that it's kind of small. Let's see if I can get it a little bit bigger. No, that's not helping. But I've got an index scan, a hash join, all coming from index scans. And so you don't see a fetch in here, which is good at this point. And then a filter. Now, you're seeing a couple of keywords here, and I didn't talk about this. This use hash keyword here on the right side of on just after this join statement and this one here. What this does is it tells the query processor to download the index and then create a hash table in local memory that it can scan repeatedly as it's processing the join. And so it did that for the consumer profile vals and the consumer profile groups, and it built those hash tables locally. Otherwise, it would be scanning those indexes 20,000 times for in order to process the join for the rest of them. So I don't want this. I don't want the repeated index scans because the query would take like 30 seconds. In that case, I do want to instead use these hints here so that it will build these hash tables locally. So I did that. So we have good join performance here. And now the last I'm going to show you here in the JavaScript. Let's look at another script here, and this is basically, you know, this former script that I ran for you. I've just replaced everything here with the Couchbase stuff. So I've got a Couchbase connection here. I've got the first query that we've just written here, and the second query, and then we're going to run through that same loop logic. So I'm going to run the first query. I'm going to populate my document, and then in order to populate CP vals, I'm going to run the second query, and we're going to get the data out of Couchbase that way. So let's do that now. $100 results, just like that. So the same format that we saw earlier, and this is exactly what we were looking for. So we just got to the point where we have taken relational data, we've pulled it into Couchbase, and now we've queried it using a nickel join in the same pattern that we were doing against the relational system, and got the same results. Okay. Back to the presentation. Finally, we're going to experiment with some denormalization. So now that I have the data in Couchbase, I can now work with it and experiment with denormalization. One of the first things that I can do is, since I have these two queries that I've been running in my application, I've got this the one that I've been running to get the set out of the initial join, and then the other one to get the profile vals. Well, what if I could just, now that I'm running Couchbase, I know that I can build projections with nested structures. Why don't I just do it in one query? Great question. In order to do that, I've got to make a couple of adjustments. The first adjustment I have to make to the query, and this is basically what this is on the right side, is I'm adjusting the top query in order to include what's on the bottom in blue there. I changed that first join into a nest, and that's a special join in Couchbase that's going to take those and nest those together in the namespace. And then I'm going to add this array projection here that's going to look for that profile key code and that profile val, and it's going to put them into a JSON structure for each item in consumer profile val. And then I'm going to grab the group instance from, the group instance ID from the group instance rather than from the distinct val, because I'm already doing the nest, which already does the distinct functionality for me. So now what I'll have is one query that does the work of two queries. And then now that I have this, I can put that into my JavaScript and use that. But I can also take that and actually use it to insert denormalized data back into the data set if I wanted to. So if I wrap that projection, if I add to that projection a key generator here, I'm going to create a key that's prefixed with cpgi-den for denormalized group instance documents with the key group instance key name, and then wrap the rest of the projection in a JSON structure as V. Then I can insert those into the data set, and I should have 3,905 denormalized instance documents there once I do that. So A couple quick notes on JSON document structure. We do have some limitations here. You have 250 UTF-8 characters per key. We have about 20 megabytes of document size limitation. Just keep in mind your schemas are not fixed in Couchbase, so you can continue to do this and work on it as you evolve. This is one of the advantages of being in Couchbase, that you can sort of experiment with these things as you go forward. Okay, so last micro demo, and then we'll have question and answer. We're going to run the denormalized query, the query that actually gives us the denormalized results, the query that does the work of the two queries. We're going to run we're going to actually denormalize the data. We're going to run the select portion of that insert statement so you can see the JSON structure is being built, and we're going to insert those objects in there, and then we're going to query for those as well. All right. So let's go back here. And we're going to do this straight out of JavaScript. I'm not going to do it all in the query browser for the sake of time. But I've got this one. This is the denormalized query together as my only query, and then mapping it to the document, and then writing the document to the console. And we're going to see that the denormalized query actually do its work. So you see here, I've got the array statement here, I've got the nest here, and I've changed this up here as I showed you earlier. So let's look at that real quick. This is 5. That one took a little bit longer. Let me fix something in here real quick. I should have taken this use hash. No, I should have taken this out. Don't need that anymore. It actually gets in the way in this case. Okay. There. Okay. So we have the same results coming back with a single query. So that's kind of cool. Instead of using the two queries and going to hit the database repeatedly in order to get the data, I can go and ask the database one question and get the nested structures back cleanly that way. So there's application optimization to be done there in that case. Now, the second case is to actually look at what can I do from adding denormalized documents back into the database. And so for that, I want to look at the modified version of our join query, where I've got the key generator in here, and I've got the rest of the projection here wrapped in this JSON structure. So I'll have underbar K and underbar V in my results set. Let me add quickly a limit 1, and I'll execute that. Okay. So my underbar K, this is a key. And then my value is this JSON structure down here with the vowels actually encapsulated there in the array. And I can write that straight to the database if I want to. And all I have to do now is add into the beginning here, insert into profiles. Key underbar K, value V. There, I want to take the limiter off. Execute. Now what I'm doing is running that query, and I'm going to write all the results back to the database using the keys. The key that I generated is the key, and that JSON object is the value. 3905 mutations there. Okay, so now I have this data in here, and what I can do now is query for that data using this query, select value profiles from profiles, where I'm filtering for my new denormalized object type, and then I can get 100 of those back, and then run the same mapping logic and putting that out there in the console. There you go. All coming back just straight out of the database. Now you can also use this as well. This is very convenient for using the key value API so that you can do just direct gets of individual profiles and of course all the things that you're accustomed to hearing about from Couchbase. Now, but we now denormalized post data ingestion. We actually had the data within Couchbase in relational form, and then we've now added to it the denormalized documents that we can experiment with as we go forward. Okay, so that completes, I think, my presentation for the most part. Next steps, there's all kinds of opportunities for you to experiment, train, attend events, network with us, and contribute. I encourage you to do one or more of all these things in order to take your skills to the next step. In particular, we'll be at AWS reInvent. We have a NoSQL Summit coming up in Kansas City and another mobile workshop in Vancouver in the month of December. So keep that in mind. All right, I went 5 minutes over. I apologize, but we're here now at the QA session of the presentation.
Great. Thank you so much, Benjamin. We do have a few questions that have come in. And audience, if you do have any more questions, please post those in the questions panel. The first question that we have is there a way to enforce data constraints for data migration?
You would, so I showed you the CB import tool today. The CB import tool is actually not my preferred way to bring data into Couchbase. My preferred way is to actually do it in the code. So if I'm using JavaScript, and if I'm reading data, if I'm reading my data out of the relational system, I would rather just use that same code in order to write it into Couchbase. Just add the Couchbase connector in there, and then just write it into Couchbase and have full control myself through the code. What you didn't see is Couchbase reaching out to a relational system and just pulling data in. That's not something that we offer. The data has to we as developers have to bring the data out of the relational system first, and then we can take that exported data back into Couchbase. Now, if you have things like a Kafka framework or something in your environment, now you could use Kafka in order to bring data into Couchbase as well from a relational system and bring it in completely flat. Now, Couchbase will just receive the data. It will not enforce any schema. It will not do anything like that as the data comes in. Now, if you bring that data into a staging bucket, for example, you can use Couchbase as a venting framework to write, cluster-side JavaScript code that can validate data, augment it, transform it, whatever, and then rewrite it back into your production bucket or whatever, if you will. And yes, so you can build those things into Couchbase using the eventing framework. Did I answer that question?
Yes, great. Okay. Thank you so much. The next question that we have is, from a query performance standpoint, how do joins perform compared to, say, Oracle or SQL Server?
That's a great question. So you saw me running a single node of Couchbase in a Docker container here. You will see greater latencies. If I was running a single node of MySQL or Postgres or another relational system here, those systems will give better latencies generally than Couchbase will single node on my local system. There's a good reason for that. As I showed you, it's that distributed architecture, right? We have the data storage is stored as a key value store with a key value API. The indexer is a separate process, and the query processor is a separate process. And these processes are all communicating with each other. So there's overhead to that. However, when you want to scale and you want to build a system that is that can process, tens of thousands of secondary lookups per second across thousands of, for thousands of clients, Couchbase can elastically scale to this workload seamlessly with no downtime. So if I was in the cloud starting out, I would be able to scale it up dynamically and be able to serve that with consistent latencies across all of those. And that's something that our relational friends struggle to do, which is the reason that we have this architecture in the first place. The second part of that is from a performance perspective, is that flexibility, right? So this goes back to the why NoSQL question. Why would you go on NoSQL in the first place? Well, you go on why NoSQL because you do want schema flexibility. You do want 100% uptime. You do want a distributed shared nothing architecture. You do want the added capabilities that are built into the thing so that you can do full text indexing. You can do other kinds of queries in the same system. You can do eventing and the mobile stuff that we do. And you do have your data available both maybe in relational form initially, but also in that denormalized form perhaps, so that when you do key value operations against it, you get your lowest latency access to object data that you can possibly get. And that's something that the relational systems can absolutely not do. They could not deliver user profiles with sub-millisecond latency in the way that a denormalized form in Couchbase that's cached in memory could. So hopefully that answers that question.
Perfect. Thank you, Benjamin. The next question that we have is everything mentioned in today's demo available in the community version?
That's a great question. Thank you for asking that. We are actually in the process of enhancing Community Edition with additional developer features as we go forward, and we're actually looking for and soliciting more feedback. And in fact, I'm the head of developer advocacy, so if you've got feedback in terms of what developer features you'd like to see in CE that haven't been there, please tell me what they are and leave us feedback in that regard because we want to hear it. The second part of that is, yes, I do believe that in the current version, the use hash keyword is not available in the Community Edition. That will change. And so we've got a number of developer features that are being enhanced in 6.5 for CE. So, what's not there today will be added here in the near future. So, thank you for asking that. But the join, the join syntax, the ANSI join syntax, that other stuff, the indexing is there, being able to support covering indexes. You saw that I used a standard GSI indexer. I didn't use the in-memory only indexes. That's all community stuff like that. I can't think of anything else off the top of my head.
Awesome. Thank you, Benjamin. We do have one more question that has come in. So the next question is, what is the performance benefit of embedding a document versus keeping it separate? Is it quantifiable?
I think that the performance benefit for really has to do in how many times you have to go to the database. So if you're really looking at eliminating network latencies, right? And so if I only have to go to the database one time in one request to get the whole object back, then that's inherently going to be faster than if I have to go back to the database multiple times. And so it's the reducing the number of database accesses that you have. The second is that if that whole object that you're actually going after, there's the architectural pieces that go along with it. If it's cached in memory and all this other stuff, then you get all those benefits too. But really, the first metric is about how many trips to the database do you have to make in order to build your object. And I think on the cluster side, since you're looking at services that are potentially distributed, there's a performance benefit to doing the first, the query that actually builds the object for you from the relational set. There's a performance benefit because that means I only have to go and ask the cluster once for the data, but the cluster on the back end still has to build that for me. So there's still some benefit, but not all the benefit. Now, if I actually embed the structure in the denormalized document, well, then not only don't have to go through the NCL API, I can go straight to the key value store with the key value request, and I can retrieve that with actually minimal network hops there, because my SDK is going to go straight to the node that's hosting that object to that vBucket, grab it, and bring it back in one operation with one network hop. So that would be the advantage.
Great. It looks like we do have one more question that we can fit in. The next question is eventing available in CE?
Oh, yes, no, it is not. Not today.
Well, great. It looks like that's all the time we have. So Benjamin, I'd like to thank you for a great presentation today. I'd also like to thank today's sponsor, Couchbase, for providing the audience with a great webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that'll help you further your developer career. Have a great day, and we'll see you next time.